All right, so we did not have homework, but we started talking about, we brought our scope stack up to um, where it needs to be. We updated our apply expression to work on our updated scope stack. So our ENV here, our environment is a scope stack based environment. And this guy should now work on that. I think we left one thing kind of undone. Because we do need to consider the impact it has on our environment. So we're kind of stuck at this position now where we have, we introduced a new thing last time called setBang, which allows us to update a variable. All right, so this allowed us to update a variable in here. We considered adding something like that, probably want to add something like that to our language, some kind of define, or you can name it whatever you want, but something that allows you to, well, we already have a var expression that allows us to, actually we have a var expression, we don't actually have a define expression, something that would add a brand new variable to the, so we kind of make a list here. It would probably be helpful for us, oh, here's an example here. So we might say define A3, where this would create for us, here's the result of that. So we talked about this at the end of class last time. This would give us a to list because now our apply expression always generates to lists. The to list is the result of applying the expression as well as the resulting scope stack that came out of it in case that's something we need moving forward. So if we do define A3, and this was our starting scope stack was up here, this would give us a scope stack that now has another local variable called A3. So a define creates a brand new variable. Now, we also want to have the ability to update an existing variable, which will go through our scope. So right here, we have our all right, so here's the scope stack that we were using our examples off of right here. So we have something that has exactly, well, this guy only has one scope in it, a C5, a C7 and an A5. Do we still have that here? There's C7, A5, A3, B3. Do we add stuff here? Well, I think we weren't operating off of that. I think we were operating off of this guy. So if this was our scope stack, where we have, we just have one scope in there, right? Well, it doesn't look like we operate off any of those. Did we just make up a scope here for this guy? So if that's the case, let me just break this out of here just so we can clarify what we were doing. I'm going to steal that. I'm just going to give us a, because we were looking at a block inside of a block. I'm going to give us this scope stack here. We're going to go ahead and get rid of the closes that. That closes the scope. This closes the scope. This closes the list. This closes the stack. All right, so if our scope stack looked like this, and then we had a block function that said define A as 3, this is going to create a new variable within the most local scope, which is the first scope that we run into in our scope stack. So that produced for us a scope stack whose first scope, who used to just have a variable B3, now has a new variable A is equal to 3 in there. So this is the resulting scope stack from last time. All right, and then we decided, well, what would be the appropriate thing for apply expression to return for an expression that is modifying the scope. So this is like an extreme example, right? This is we're thinking about, well, what happens if we have a block expression where somewhere along the lines in there, the scope might be modified. Well, now we have an expression that we know, its only impact is that it changes the scope. This guy adds a brand new variable to the scope. So in actuality, the result of that guy is the new scope, but we already get the updated scope passed into that comes out of our to list that we're returning from our apply expression now. So we decided what was the appropriate value to return after we expanded the scope. We can return the value of A. I think if I remember, you mentioned maybe return the variable name. Both of those are valid. You can decide what's appropriate for your language. Maybe you can even return a true or false, whether or not it worked. Something like that, like to make sure that the variable was defined. Maybe it would return a false if you already had a variable define that. In an example, if you already have an int a equals 5 in your Java program, and then 2 lines later you say int a equals 3, it's going to yell at you, saying there's already a variable in the current scope named a. So maybe you'd want it to return true or false, whether or not it did in fact define the brand new variable. That might be handy for like error checking, that kind of stuff. Right now for us, it doesn't necessarily matter because this is one of those values you probably would not use, at least not very often, right? Usually when you say int a equals 5, your only intention was to create a new variable. You're not using it directly right then. You might use it on the next line if you want to print out a or something. All right, so let's just leave it at, it'll return that to list, the updated scope, and the updated scope stack, and then the value. So let's go ahead and let's add a define to our parse. And then let's add, so define for this guy is going to give us, do we write it up here? This is kind of what it would look like. Define expression. So we decided that's maybe what our parser for our parse expression would spit out for a define expression. All right, so let's update that guy first. So here's parse expression. Anything after these first 3 is guaranteed to be a list, so we can throw it anywhere in there. So we'll do EQV, car, EXP, and do we want it to be defined? Or do you like a different kind of name for it? Some programming languages will say var something, like var a equals 5. Scheme tends to say like define a 5. So we can use whatever we want. Do we have a preference besides define, or we just want to roll with define? Go with define. Okay. So if the car of the thing we passed in is defined, then what we're going to do is we'll generate a list called define exp, and then that guy is going to take in 2 values. It's going to have 2 values. That is going to be the variable name we're defining and the value of what we're defining. Okay, so the variable name we're defining is the CADR of exp. CADDR is the value. So the car of the cooter was going to be like that A. The car of the cooter would be the 3 for A equals 3. All right, so that guy should give us a well-written define. Let's just test that real quick before we go any further. So we'll just steal this this line here real quick. We'll go up to our so this is going to be a define. This needs to be quoted. All right, so we're going to define B is 5, and we want to see what P1 looks like. So I'll just go ahead and print out P1 here. And then I'm going to, well, actually, I'm not printing out P1 yet. I'm printing out parsed P1. That should be my parsed version of my expression. And then I'm going to go ahead and just dump all these things after that. Actually, I can define these. That's not going to hurt anything. I can show the scope stack. I can do that. Oh, I'm actually already showing everything I need to show. I'm not actually calling apply program. So I already have exactly what I want. The last thing we'll see should be our parsed version of this expression, which should be our define exp. This is but receive define. So here's our program, and here's our define expression, and here is our, that's not the way we want it to be. So this guy should not look, it's not going to look like that since this whole thing is quoted. Yeah, here's our define expression B5. So we had poor initial syntax. And here's the parsed version of that guy wrapped inside of a program. So it looks correct enough. All right, so now we need to teach our apply expression to carry out the define expression. So I'll come up to apply expression. All right, so after these first three, we'll go ahead and put it in the same place as we did the other ones. So we'll do EQV, get parsed expression. I'll just steal this piece right here. And we're looking at this guy being a define expression like that. All right, so if I'm looking at a define expression, I know I need to now expand my given scope. So I'm going to be making some changes to the ENV I'm currently working with. And that is I'm going to take the current most local scope and I'm going to expand it with a brand new variable. Now for right now, we can probably assume that it's a brand new variable. We've already had a pretty good pattern of not doing a lot of error checking. Not because it's the right thing to do, but because this is already complex enough without extra error checking. But so we'll assume that they're giving us a legal new variable to define. We won't check to make sure there isn't already an A. But we do need to make a change to that. So if we're here, we know that what we're going to be producing is going to be a to list, right? Where the car of that to list is going to be, in our case here, the catter of our define expression, which is going to be, actually no, the CADDR. Catter would be Jonah's version, right, for the variable name. CADDR would be my version, which gives you the value. Pick your poison, but we're going to have a list that we're going to spit back. And the first element of that list is going to be CADDR of parsed expression. Okay? So that'll give us the value of that variable. We've done nothing, no processing. This is the easy part. Okay? So the result of my define expression is to just spit back the value we were setting. Fine. Now the second part of that to list, though, is going to be, let me actually, just for a little bit of space saving. Yeah, that'll be some pretty decent space saving, actually. Let's kick it down to this line. So we'll return a list containing the number that we're setting, followed by the next thing should be our resulting scope stack, which should now be our expanded scope stack. So let's look down here. Do we have a function that we've written yet to add a variable to our scope stack? That would probably be handy, right? Being able to have a function where we can create a new variable. All right, so for the moment, I'm just going to circle off the end of that list. So right now it just returns a one list. Okay. So let's go back up to our scope stuff. So this guy resolves a variable in a scope. Well, this resolves a variable in a scope stack. This resolves a variable in a scope. What we want to have is we want to have a ability to add a variable value pair to the most local scope of a scope stack. That's going to be a handy tool to have, right? All right, so we've already kind of written some code that will allow us to get the most local scope. Because what does our scope stack look like? Our scope stack, here's the scope stack right here, so is a list whose first element is a scope stack, and then following that is a flat list of scopes. So the cdr of this guy will be a list containing scopes. Correct? The car of the cdr will be the first scope. So that's the scope we're actually expanding here. All right. So why don't we write this in two pieces, similar to what we did before, just in case we ever need the ability to add a variable in a local scope. Because we're probably going to be doing this here fairly soon, where we're going to be creating our own version of like a setbang to update the value of a variable within the scope. So we're going to need kind of that control over an individual scope, and we don't necessarily know what scope we're going to be dealing with. So let's do a define. I'll kick this down the line. So we're going to define add pair to local scope. This guy's going to be a lambda that's going to take in a scope stack of our name and of our value. All right, and I'm just going to stop that here for a second so we can write our second part of this. So now we're going to have a define add pair to scope. This guy would be a lambda that takes in a scope, var name, var value. Round it off there. All right, so now the body of add pair to scope, or to local scope, we can choose whether or not we want to have some error checking and whether or not we don't have a scope. So we kind of do that up here, don't we? We say, if it's an empty scope stack, return false. So we could certainly do that. We already have a function that helps us test for that. So if I just steal that guy from there, we can say, if I have nothing in my scope stack, I have no scope to expand. I'm done. Otherwise, what I want to do is I want to call add pair to scope, passing it my most local scope, which is my car of the cdr of scope stack. The cdr is a list of scopes. The car of that will be the very first scope. Var name, var value. All right, so that's what we'll actually be doing in add pair to local scope. That'll pull out the most local scope. All right, now we're going to have to come back here in a few minutes and put our scope stack back together, right? Because ultimately, this guy is going to have to return for us a scope stack. All right, so given a scope and given a var value, I'm currently looking at something that might look like that. In fact, in our example here, it would look like that. And let's say I'm trying to add an A equals 5 to that. So what I need to produce is so the way our scopes work is it's a scope followed by a list of pairs, right? And we want to add a new pair to that list of pairs. And that new pair is going to be the pair created by our var name and var value. All right, so we know that we're going to be generating a new list that contains the word scope, or if we want to make this more generic, contains the car of our scope, just in case we change the wording of our scopes. It doesn't say scope, it says SC or something like that. You know, if we try to shorten it, this will make it so it's not, this would be called coupling if we have the variable hard-coded in here, where it's reliant on things being a certain way. Where in this case, we're just saying, whatever you give me, I'm going to take the car of that. That's how I'll describe my scope. So we're building a brand new scope here using the pieces that you gave me. All right, so we're going to create a list out of that guy. So that's going to be the car of it. Now, following this is going to be another list. It's going to be a list of scopes. I'm sorry, a list of pairs. List of pairs. Because we're looking at something that looks like this. Okay, that's our list of pairs. So I need to create a new pair, add it to that list of pairs, giving me a flat list of pairs. And that's going to be the second element of my list. So how do I glue two lists together, making them one list? Append. Append. Cons will add an element to the front of a list. Append will take two lists and make them one list. All right, so I want to append. Lost. Where am I here? I'm still lost. Here we go. So I'm going to append my new pair. Actually, let's think about this for a second. We do want it at the front of the list. We do want a cons here. Let's create our pair first. So we're going to create a list out of our var name, var value. That's our new pair. That's the guy we want to have onto the front of our list of things. So we will cons that guy. So this is our new pair onto. So our scope looks like this. I need to cons it onto this piece. So that's the car of the cooter. Will be the list of pairs. All right, and so that'll create a brand new scope for us. Just out of curiosity, did we write a, let's get first pair, get rest. Oh, we do have a get first scope. Probably should have used that down at the bottom, right? So I add pair to local scope. Instead of catter here, get first scope of scope stack, which is the catter, but should use our tools that we wrote. So this add pair to scope is going to generate for us a modified scope. We then need to do something with that modified scope. So this guy right here is going to give us a modified scope. I need to now add that scope to the front of my scope stack. So let's go back and look at our tools here. We have a get rest of scope. So this will give me everything but the first scope. Do I have a ability to add a scope to the front of a scope? Extend scope stack. Right here. So we want to get the rest of our scope stack. and we're going to extend our scope stack. Maybe I do this in a couple of pieces. So extend scope stack, lowercase e ss, takes a scope and a scope stack. The scope we're going to send it is the result of our add pair to scope. And then the scope stack that we're going to give it is the rest of our scope stack. So extend scope stack. So extend scope stack is the guy we're going to pass it. The scope, what did it take first? The scope stack that we're extending? No, the scope that we're extending it with. So here is the scope. So that's the scope we're extending. And what stack are we extending? Oh, that's the scope we're adding to it. What scope stack are we extending? We're extending get rest scope stack of scope stack. All right, so right here, we're taking the very first scope from our scope stack, and we're adding a pair to that guy. So this right here will boil down to a modified scope. This guy right here will boil down to our original scope stack with the first scope removed. Then we're extending that scope stack with the first scope removed with our now modified first scope to give us a updated scope stack. Make sense? So we'll call add pair to local scope. So we'll go all the way down here to our apply expression. If we're looking at a define expression, we're going to create a list containing my result, my value, along with add pair to local scope. Add pair to local scope takes the scope stack, which we have called env. Then we need to give it the variable name, which is the car of the cooter of exp, of parsed expression. And then the car of the cooter of parsed expression. Get this down the line. So car of the cooter of parsed expression, this is our variable name, this is our variable value, this is the scope that we are extending or modifying. That's the end of that result, so this will create a to list. The first element is going to be the value. The second element should be our extended scope stack. All right, and that should be it for a define expression. So now we should be able to test this on our apply expression and see that it gives us a properly modified scope stack. So here's our apply program on our parsed P1 and our scope stack. We have been printing out our scope stack, and what are we trying to do? We're trying to do I've said B5, what have I, oh, I've said B5 here. My scope stack looks like that. So let's actually do a D3. That way the first new element will be a D. All right, so we're going to define a D3, which should return for us a 3 followed by this scope stack with an extra pair in this first scope that should say D3. Yep, so here's my 3, the value. Then here's my resulting scope stack The first scope has an extra pair now called, that's D3. Make sense? Okay, so now let's think of this from a block expression perspective. That's where we're going with this. So let me match these things up. So I might say, let's do D3 and then D like this. So this would be my original expression, original syntax. My parsed syntax would look like this. Just labeling it so you have it correct in your mind for your homework. Okay. We might start with a, well, it doesn't really matter what we start with because you have your global scope up here. So let me just steal that guy. This is the initial scope stack for no other reason than that's the example we've given ourselves up here. Who knows how we came to get to that scope stack, but that's what we have. All right, so we have that scope stack. And then I want to get rid of this stuff. All right, so here's our block expression. The block expression has two expressions in it. We typically, when we have open and closing curly braces in Java, we do these things linearly, right, or sequentially. So the first thing we would do is we would expand our scope stack. The second thing we would do is we would execute this expression in the newly modified scope stack, which should give us the 3 out of that. All right, so what we want our output to be for this guy, I didn't spell initial correct. Initial does not have a U in it. So let's just dump these lines for right now. So the output of this program should be this guy first. I'll just go ahead and comment the front of each of these just to, because I think it's easier to read like this. Actually, I'll kick that up there. So this is the first output. So we'll call this guy result of the first expression. And then the second expression should just give us a 3, the value of the D, because that's what we've asked for. Here's expression 1. Here's expression 2. Here's the parse version of it. So we get this thing called a block expression. Here's expression 1. Here's expression 2. We don't parse, we don't execute or apply this expression until we have completed applying this expression. And we apply this expression in the resulting scope stack from this expression. Does that make sense? This guy might have a different output depending on what happened with this guy. In fact, in our case now, it certainly would. if we executed all these at the same time, what would the output of this guy be if it didn't get the scope stack of the first one? I think false, right? Can't find a variable named D. We didn't have it in the most local scope. We didn't have it in the more global scope. So this guy's getting a value out of this guy is going to rely on us having a scope stack returned from this guy and then us using that scope stack to apply this expression. All right, so this should be the result. Actually, I'm going to steal some of this here. It's actually kind of a bad example because the result of both of them will be identical for different reasons. So I'll mention that here in a second. This is the result of the second expression. So both of these guys have the identical result. This first guy, his version of the result is because of, here's the value of that variable that we're defining. And here's the resulting scope stack that has now changed. The second guy, this is the second expression. This is the result of resolving that variable, D, which gives us a 3. And here's the unchanged scope stack because resolving it did not modify the scope stack. So this actually would look better for us if we use Jonah's version of this, where we return the variable name for no good reason. If we did that, then this guy would say list D like that. And this guy would say list 3. Because this is the value of the resolved variable, where this one was just whatever the value we decided was appropriate. Or maybe we returned the true that it worked or something like that. Let's actually, since we have a couple minutes, let's do the true-false thing, just so it's ready for error checking in the future if we wanted to. So just a small little change we'll make up here. So here in our extend, let's see if it's empty. Boiling down to, oh, we do it actually in apply expression. So rather than getting the value, that guy right there, I'm in the wrong place. Rather than getting the value, this guy right here, we're just going to get a true. Assuming it worked. Make sense? We'll even put the little thing. Assume the define works. So then down here, I'll go ahead and run this again. You'll see that our result is a true there. So the result is a true for our list, followed by the updated scope stack. So it's true. This guy will then be a 3. The correct resolution of that variable. Okay, so for homework, implement block expression in the parser and the apply expression. It should work for any number of expressions. So you could have a block expression that has 0 expressions in it, or you could have a block expression that has 30 expressions in it. Expressions are applied sequentially so that the resulting scope stack of the previous expression may be used while applying the next expression. That make sense? All right. Questions, comments, concerns, bribes? All right, I'll put this up on Slack, the current version of our code, and then I'll put the assignment up, and I'll see everybody on Wednesday.